Good afternoon, it's Chris Potter, May 20th, 2017. I'm sharing an article with you from phys.org titled Punching Above Its Weight, a brown dwarf launches a Parsec scale jet. This is only dated May 18th, 2017, and as you can see, brown dwarfs appear to be a hot topic. The HH-1165 jet launched by a brown dwarf in the outer periphery of the Sigma Ori cluster, traced by a mission with singly ionized sulfur, which appears green in the image. The jet extends 0.7 light years, or 0.2 parsecs. Astronomers using the Soar telescope, yet another telescope I've never heard of, at the Cerro Tololo Inter-American Observatory report the discovery of a spectacular extended jet from a young brown dwarf. With masses too low to sustain hydrogen fusion in their interiors, brown dwarfs occupy the mass range between stars and giant planets. While young stars are commonly found to launch jets that extend over a light year or more, I had no idea. This is the first jet with a similar extent detected from a brown dwarf. The result lends new insight into how substellar objects form. Intrinsically faint, brown dwarfs have been more elusive and difficult to study than stars, although they are often portrayed as exotic creatures as a result. Brown dwarfs are actually far more numerous in our galaxy than stars like the Sun. The discovery accepted for publication in the Astrophysical Journal supports the emerging picture that brown dwarfs form similarly to stars. The image shows the jet HH-165 launched by a brown dwarf Mayrit 1701117 in the outer periphery of the 3-million-year-old Sigma Ori cluster. Traced by a mission with singly ionized sulfur, which appears green in the image. The jet extends 0.7 light years, which is equivalent to 2 parsecs, northwest of the brown dwarf. The emission knots along the jet reveal that the mass loss is a time variable, probably as a result of episodic accretion onto the brown dwarf. Did you get all that? The red nebulosity southeast of the brown dwarf is a reflection nebula that traces the outflow cavity in the direction of the counter jet. While outflows have been detected previously from young brown dwarfs, the early detections were of microjets 10 times smaller in extent. Our result shows that brown dwarfs can launch parsec-scale jets similar to those from young stars. The image taken from the Soar telescope using the Soar adaptive optics module was obtained in several hours of integration time, as described by co-author Cesar Bracancho. We could see the surprisingly extended jet emission after the first 30 minutes of integration. It was a real wow moment. This is the Soar telescope at sunset in Cerro Pachon, Chile. For some time, the astronomers have suspected that brown dwarfs form much like stars. Like stars, brown dwarfs are known to be surrounded by disks at birth and to build up their masses by accretion from molecular cloud cores. The current discovery goes a step further and shows that, like stars, brown dwarfs launch powerful jets and that they build up their mass through an unsteady episodic process. The HH-1165 jet shows all of the similar hallmarks of outflows from stars: emission knots, a cavity reflection nebulosity, and bow shocks at the end of the flow. It checks all of the boxes quite convincingly, commented co-author Emma Whelan. While it may seem counterintuitive that mass loss in a jet is an integral part of how an object grows or gains mass, the situation may arise because of axis angular momentum. When spinning skaters pull in their arms, they spin faster as a result of conservation of angular momentum. Similarly, when large, slowly rotating molecular cloud cores collapse, they may spin up too fast to squeeze down to the much smaller sizes of stars. Rias speculates that indeed molecular cloud cores have much more angular momentum that can be contained by stars or brown dwarfs, so the system needs to lose angular momentum for the object to grow in mass. By removing angular momentum from the system, jets help solve the angular momentum problem faced by stars as well as brown dwarfs. To test this hypothesis, the team is on a hunt for more extended jets from brown dwarfs to understand how commonly they occur. So just to reiterate, this was the picture HH1165. I'll put the link below. Thanks for watching. Thanks for subscribing. Have a friggin' awesome day. Take care, boo.